Hi guys, this is Mr. Miller. We're going to go over series and parallel circuits together. Alright, so as a quick recap, what are circuits? Circuits are devices that convert electrical energy into other forms of energy. They're loops of metal, typically, that provide a path from the negative terminal of a battery to the positive terminal, or as we'd prefer to say, high concentration of electrons, high voltage to low voltage, low concentration. All right, and so when we have a complete circuit, and say this operation game, and we, say have touched our tweezers to metal, we've completed the circuit. There's now a path from the negative plate of a battery to the positive plate. Our electrons are going to flow through the circuit, and as they, move, they're going to go through different devices. Our buzzer is going to convert some of the flowing electrons, or electric current. It's going to convert that into sound energy. And then our LED lights are going to convert some of the kinetic energy of those electrons moving into light energy, photons, right? Okay, and so circuits are set up in one of two configurations, series or parallel. And let's take a look at those, because it's important to start with these two, because more complex circuits will add these together to form compound circuits. All right, but our houses are parallel circuits, and our operation games that we're building in class are series circuits. Okay, and so the pros and cons are pretty straightforward. A series circuit, we can see that all the components are placed one after the next, right? Okay, and the downside of a series circuit is that, say we have, connected our battery through a series circuit, and then something happens such that our first light bulb breaks. Well, if there's a break in this circuit, the circuit's no longer closed. That means that electrons can't flow, and so each of these light bulbs will turn off if one of them breaks, because there's only one loop, right? Parallel circuits are a little bit more robust in the sense that you have multiple loops, right? We can see one loop here, one loop here, one loop here. All right, and so if our first light bulb breaks, well, there's still 1, 2 loops for our electrons to flow. Okay, and so most, you look at your cell phone, you look at your computer, it's not going to be, just a series circuit or just a parallel circuit. It'll be a combination of the two. But since we like to, make predictions in physics and do the odd calculation, one of the most important aspects of circuits is looking at electric current, because electric current is the kinetic energy of electrons moving, and energy is our universal method of accounting in physics, right? Whenever we see a change occur, energy is gone from one form to the next. All right, and so looking at series circuits, the analogy we like to use, like all circuits, is water. If we say have a motor, our motor is a little bit harder for electrons to move through than a wire. And so if we take our water analogy, we use our battery as our pump, right? It's trying to force water through our conductors. And so when the water or the electrons get to our motor, it acts as sort of a choke point. It's got more resistance than the wires themselves. And so it's a little bit harder for water to flow through it. And say, what if we were to add up multiple motors in series, right? We can see just based on these diagrams that if each motor acts as like a choke point by adding resistance to a circuit, then, if you just compare these two with just a single motor versus 3 motors, the total resistance has gone up, right? In the case of the 3-motor situation, right? There's quite literally less pipe or less wire with, the standard thickness, the standard resistance, all right? And so if we want to, say, calculate the current through a circuit with components in series, we're going to apply Ohm's law. Current is equal to voltage, electrical pressure divided by resistance. Okay, but what is the total resistance here? Well, we can just see that, each one of these 3 motors has a compounding effect, right? So the total resistance, we just add up. So say these are all 2 ohms, 2 ohms, 2 ohms. Our battery is 12 volts. That would be 2 ohms plus 2 ohms plus 2 ohms. That's 6 ohms over 12 volts. We get 2 amps. Okay, simple as that. All right, parallel circuits, again, a little bit different. What happens to resistance in parallel circuits is almost a little bit counterintuitive, but let's just take a look at it. So again, same analogy. Our water and our motors, our battery acts as a pump for electrons, or in this case, we're talking about a pump, so water being pushed by a pump. Okay, and so our motor's providing, again, our resistance, our choke point, a narrower pipe. Okay, and so now we add a second motor in parallel to the first one. And even though they have the same resistance, we'll say 2 ohms again, notice how we went from one narrow pipe to 2 narrow pipes, right? According to the battery then, or the pump, it's now easier for electrons to flow. There's less resistance overall than there was before because there's 2 narrow pipes for the water to go through or the electrons to move through than before. There's only one before, right? Interesting. So when you add components in parallel, the overall resistance goes down for the entire circuit. But let's just do a quick calculation. All right, say we have a 6-volt battery, and we have two 2-ohm resistors. We'd say our total resistance, if we use this equation right here, is equal to 1 over R1 plus 1 over R2. And that becomes 1 over 2 plus 1 over 2. Well, 1/2 plus 1/2 is 1, so we get 1 over 1, and that's equal to 1. So our total resistance is 1 ohm, whereas previously each one of the motors was 2 ohms. All right, so that kind of makes sense, right? It's easier for water to flow with more components in parallel than before because there's more thin pipes than before. All right, so we calculate current. Current is equal to voltage over resistance. And so we get 6 volts over 1 ohm, and we get 6 amps. All right? Simple as that.